Okay, today we're going to do a lesson using a TI-84 graphing calculator to solve quadratic equations. The necessary equipment for the students is going to be a writing utensil, a piece of paper. I prefer graphing paper for obvious reasons. I'm a mathematician. A TI-84 graphing calculator. For the presenter or the teacher, you're going to need a TI-84. Again, it can be any TI, but it's best if everybody has the same calculator. I work on a TI-84, in this case a TI-84 Plus, which just has some additional software put into it. You're also going to need some sort of projection machine, whether it's an overhead with an attachment that allows you to project the TI inputs and outputs, or if you've got a small class, you can typically just have everybody just sort of gather around. Okay? So once you've got everything squared away, you're ready to start your lesson. We're going to go ahead and set the stage today by having the students do something with a quadratic equation, specifically to solve it, but they're going to start, just to sort of get the mathematical juices flowing, we're going to have them start it by solving an equation analytically or algebraically. So we're going to start with, let's go 3x plus 10 equals x squared. So you would have your students solve this using the algebraic techniques that they've used in the past. Hopefully they would come up with x squared minus 3x minus 10 equals 0. And again, you're going to allow for time for the students to be able to solve this. They would factor, so we got x minus 5, and we got x plus 2, and we get 0. All right? Of course, if you've got students that struggle with factoring, they can always double check. You can review the fundamentals of factoring. There's lots of supplemental instruction that you can do throughout this entire process. So using the zero product property, you would set x plus 2 equal to 0, x minus 5 equal to 0, so x equals negative 2 or 5. I suppose we need to comma. All right? Now, of course, students can also double check. So again, you get an opportunity to inject some knowledge into this, some learning into this. Have them stick negative 2 into the original equation and double check to make sure that it works. And strangely enough, it does. So does the 5. Okay? All right, so after you've got that, that's a good little anticipatory set to get your class started. Now what you want to do is you really want to start getting into using your graphing calculator to solve. Now this lesson depends on some prior knowledge of using a graphing calculator to solve. So at this point I would say something like, okay, we've seen calculators solve for x-intercepts of linear functions, so let's do that really quickly. Let's recall the keystrokes that are required for a calculator to solve. All right, so we'll start with an equation, a linear equation. So we go 3x plus 4y equals 12. And then you have the students put this into slope-intercept or whatever form that they're the most comfortable with so that they can put it in their grapher. Clearly, since the grapher has a y equals, you're going to want it in y equals mx plus b, which they will discover very quickly if they try to put it into a different form. So we end up with 4y equals negative 3x plus 12, or y equals negative 3/4 x plus 3, which we're then going to plug into our calculator. I go ahead and tell students it's better to use too many parentheses rather than not enough. So we're going to go negative 3/4 x. That way there's no confusion in terms of what's dividing and what's multiplying, things of that nature. Plus 3, and then we're going to go ahead and just in case, we're going to stick it on Zoom Standard. Of course, the students will have seen all of this stuff before, so nothing's new. All right. This is the point at which you want to make sure that all of your students are on the same page as far as being able to identify solutions, or affectionately known as x-intercepts. So we go to second calc. We're going to go to zeros, which hopefully students will have seen that a solution or an x-intercept is also known as a 0. We notice that the calculator prompts us for a left bound, which can be a little confusing for students. Left bound of what? Well, we just have to get left of the place where the function crosses the x-axis. I'm going to get it somewhere close. The closer I am, the better the estimate when everything's said and done, and it's faster. Right bound, if you want to play with the guess with them, they can choose a guess, but you don't really have to worry about that because the calculator's going to solve it as long as you framed it in. And ta-da, you end up with a 0 at 4. So we know that the x-intercept of this is at x equals 4. We can have them plug that in, and it's clear that if I plug x equals 4 into this, I get y equals 0. You can also have them use old analytical methods or algebraic methods for solving simply by setting y equal to 0 and solving for for the x value. So lots and lots of opportunity to review some things. Okay, so at this point, it's really time to introduce the TI-84 as a resource for solving quadratic functions. So here we go. We're going to go back to our good friend, x squared minus 3x minus 10. Only this time we're going to name it as a function. I'm going to go ahead and move this up. And we're going to say f of x equals x squared minus 3x minus 10. And what we want to know is when that function equals 0. Well, that is exactly the same as finding an x-intercept. It works identically with the processes that we use to find x-intercepts for lines. So we go back to our grapher. We're going to go ahead and clear this out. I can either clear it out or turn it off. I can turn it off by putting it on the equal sign and hitting enter. But we got a lot of stuff going on today, so I'm going to go ahead and just clear it out. All right? I'm going to put in x squared. Let's see, x squared minus 3x minus 10. Notice that the cursor is darkened, which tells me that the calculator is recognizing this function and will graph it. I'm going to go ahead and hit zoom standard again. You never can tell. And there we go. All right. Now at this point you might want to cue your students or prompt your students to say, okay, what does it appear, what do the x-intercepts appear to be on this function? And you can have them look, oh, Ripley, let's see if I count over -1, -2, that looks pretty good. 1, 2, 3, 4, 5, that looks pretty good. Well, hey, wait a sec. That's -2 or 5. Those are the values that we found before. Huh, that's funny. But we got to be careful because of the limited capabilities of this screen. I may not know for sure that it's -2 and 5. So you want to have your students with you go through the practice of finding the zeros. So exactly the same keystrokes. We'll say count, 0. It's going to prompt me for a left bound. Uh-oh, there are 2 zeros. There are 2 solutions. So I'm an English speaker and an English reader, so I'm used to finding things from left to right, although it doesn't matter. All right? I've actually had students that were used to finding things from right to left, especially if they were used to reading things that way. But it really doesn't matter. The calculator doesn't care. So left bound, make sure I'm to the left of the 0. Right bound, I make sure I'm to the right. Don't bother with a guess. And boom. Hey, x equals -2. Okay, and then I'm going to go to second calc. I'm going to go to 0. Of course, I'm doing this with the students the entire time. In fact, they are telling me the keystrokes. My favorite line is, I'm simple country folk, I can never remember how to push these buttons. Could somebody please help me out? I may usually laugh at that, point fingers and say, yes, you are simple country folk. And they walk me through, whoa, look at that. Just like we suspected, our x-intercepts are exactly the same as our algebraic solutions that we solved for earlier. Huh. Well, what does that mean? Well,